So what I like to talk about is how to overcome the barriers to digital transformation in global B2B manufacturing companies, and in particular those companies that have complex configurable products. Before I get to that, I'll just briefly introduce Configurator. So Configurator is headquartered in Copenhagen, Denmark. We have offices in the US, the UK, India, and Germany. Our customers typically have a global presence, and we help them get value with our solutions throughout the world by delivering software products to them and help them implement it. We have an extended partner network that also helps implement the solutions. We've been in business for more than 20 years, and during that period, we have gained a lot of experience in the challenges that manufacturing companies are having with respect to complex products and the different ways you might approach digitizing how you handle your products. And it's part of that experience I'll share with you today. Configurator is ISO 27000 certified, which is a certification to ensure information security. And this is very important for us and for our customers because the data we work with are related to very essential information around the products and the pricing of the products in companies. So we take security very seriously. We work on one topic, which is what we call configuration lifecycle management. So this is about helping to deliver solutions that provide end-to-end efficient handling of configurable products. The question I'm gonna talk about for the rest of this session is this one here. So how do you get started with digital transformation when you're in a situation where products, processes, and system landscapes are complex? And I think it's obvious for everybody these days that having a digital business is a must if you want to stay in the game. So you need to support your operations internally and your interactions with the customer with a seamless digital journey. And you hear a lot about that. You hear the analysts talking about it. You read about it everywhere. I think many of us are sitting back with the question, that's all fine. I know we have to do it, but how do we get started? And this is a topic I want to talk about. First, I want to go a bit back in history because you have the feeling that this digital transformation might be something that's very recent, but actually it goes back to the 80s and the 90s. And I have found a couple of references here that are published scientific papers back from the 80s and 90s reporting on this particular problem we're going to talk about. And the title of the first one is a knowledge-based configurator that supports sales, engineering, and manufacturing AT&T network systems. So when reading that article, I found it quite amazing that in 1993, there were some people working at AT&T that realized that products were not becoming so complex that the manual processes were breaking down. If they were to be able to efficiently develop and deliver their products to the market, be able to give customers quotations and take orders on variations of their network systems that they would be able to deliver, they needed computer support. It was becoming too much of a burden and of the interactions between the different departments. It took too long and there were too many errors and they lost deals and they made mistakes in their quotations, so they lost money on accepting orders. Today, we would call what they were doing looking into digital transformation, but of course, at that time, that concept were not really well known. It goes even further back, and the other article is from 1982, and this is often quoted as the first commercial product configurator in the world. It was developed at Digital Equipment Corporation to handle a microcomputer that developed the VAX 11780 computer system. It was later also used for other of the DEC computers. But it's fascinating to see how visionary they were and what they managed to achieve. What they struggled with was these were early days for them. They were pioneers. And it's clear when you read about that and the subsequent experiences they have with the product, they sort of saw the need and what it could do for them, but it was a nightmare to maintain the systems. They had pretty bad tools when they had to develop them. So they were using some old rule-based thinking in the AI community that worked poorly for them. So, but I just want to point out, it's not a new thing. It's been around for 40 years. The dreaming of how this might help businesses be more efficient. It's an old dream. The exciting thing is that over recent years, we now have the thinking and the tools in place so you can really fulfill this dream by implement systems that support configuration end to end. Now, going a little bit back again, what you saw in the 90s, you saw a lot of offerings coming out on the CPQ side of things. That's what we call CPQ today. It was not a term that was used at the time, but this was to support sales. So a rather siloed tool that would help sales create a quotation on a complex product. It was it got better attraction. It was easier to understand, and companies started implementing that. And you'll see a lot of CPQ solutions out there today. Some companies are on the second or third generation of these tools because they see the value in it. But for the discussion today, CPQ is a pretty siloed thinking when it comes to configuration. We are thinking about the end-to-end picture. So fast forwarding to some five years ago, where it became clear that now the demand for these end-to-end solutions was really so high that it was timely to do something more systematic about it. Companies have sort of solved the siloed problems and needed to have it all linked up in more smooth processes that could support the seamless digital customer journey and have efficiency in the internal processes. So we worked with a group of people in this space from different manufacturing companies, and we had this feeling that this was a topic that needed some more attention. So we formed a little community working together to sort of define what is it we're talking about when we see end-to-end configuration. What is this problem really? What are the pains and what are the challenges, and what is it you could try to achieve if you want to find good solutions for it? And a couple of outcomes there is this definition of what configuration lifecycle management is. And there's a Wikipedia entry giving some more details and having references on what this concept of configuration lifecycle management is supposed to cover, and how you can get value out of thinking in a CLM way and moving towards it. And one of the outcomes is this green circle, which is a little graphics we often use to capture essential elements of CLM. And here you see four different business units. You have engineering, all aspects of engineering. This can be electrical or mechanical systems engineering is a quarter of the circle. You have sales, which is representing sales and marketing in a business. You have manufacturing, where you fulfill your orders, you build the products that you have taken orders on. And then the service part, which is covering everything that happens after you have delivered your product to a customer and they need to maintain it, upgrade it, or replace it. So these are the four main areas that are affected by CLM thinking, and you need to consider if you want to provide good end-to-end configuration solutions. And the thing that binds it all together is the core here is modeling. So it's about bringing the different views you need in these different business units together in a consistent, coherent perspective on what are your configurable products, what is it you can sell, what is it you can manufacture, how can you service it, what is the pricing. All that comes together through modeling. And this is often talked about as single source of truth. And it's important to understand that you need this single source of truth, but it's not the same that you need to keep all information in one place. You will have to have it come together in one place, but the sources, the master data, could be in different systems. And our perspective is, you don't do double maintenance ever. It's a basic source of problem, misalignment, errors. You find the system that's best to maintain the data you need and then bring them together through strong integrations, so you can have it all tied up. And that's the approach we take on CLM. So the 4 different main business areas glued together through what's called modeling. And I have a little picture here from the initial summit back in 2015, the first summit where we brought people together, a group of people who worked hard for a couple of days to think through these aspects. And they came from a number of different manufacturing companies. There were some analysts with insights, some who have been practicing implementing configuration systems for years, and they all agreed on this CLM declaration, which you can find on Wikipedia, saying, we all believe this is an important topic, and it's for these reasons, and what we hope to achieve by working in this thinking is these benefits. And that brings me to forward to talking a bit about how do you get started. If you sort of buy the vision on CLM, if you see the value and you can see this could be something that could benefit an organization, that you connect these different aspects of the configurable products, how do you get started? So to get to that, I have a slightly more expanded picture of what CLM is about here. So if you look at the bottom of the slide, here's a high-level value chain that I'm sure any manufacturing company has one version or the other of this. So it goes from the engineering side, where you define and develop your products through sales. So there's a phase in which, when you have engineered the product, you industrialize them, you make them ready for market. That includes pricing, getting marketing material ready. You get it into your sales channels and you sell it, sometimes as a resell, which we have added here, because you might have dealers or resellers that take your products and they sell it. That's a selling process. You take orders, and then you need to manufacture it. And here, of course, we're assuming this is a configure to order scenario where you take the configuration and then build the product. You need to source the parts, you build it, you deliver it. And in the delivery, there could be 2 aspects. There might be an install aspect, which in itself could include some configuration aspects. And I have an example of that later. And then there's the after the customer takes possession, the after sales. There's a service part in maintain. So this is another way you can sort of, I think, pictorially see how you could split up the circle and sort of map it down to these value chain view. And I have an example here what this could typically look like in a manufacturing company, inspired from by our customer base. So you could typically have a system landscape where, on the engineering side, you have some CAD tools. You have PLM tools. It could be PTC Windchill. It could be Teamcenter from Siemens. And it's not rare to have more than one PLM system in a big organization. You could have SolidWorks for CAD, and there could be some extra tools you use in your CAD development. And then in sales, many companies have legacy sales systems they've built, sales channels. It could be their web portal for selling, or it could be your own developed system. Of course, they could use commercial systems like Salesforce CRM. And if you have a multi-channel scenario, then apart from your own sales system, that could be a dealer system where they can place orders. Then there are manufacturing tools. A lot of companies use SAP as an example here, ERP for controlling the manufacturing. If you're in a big organization, you will often have more than one SAP instance. It could be one per plant, or one per region, and you'll often next to it have a manufacturing execution system. And then on the service side, you will have a maintenance, repair, and overhaul systems to help you. It could be a spare parts system or other systems that help in the service. All these systems, they work on the configurable products. And of course, when you build and develop and want to launch a new product, you need to have all these systems in sync. And that's not an easy task. And it's particularly not easy when it's configurable products, where you have to communicate all the options and the variants, the rules that govern what works with what. And this is exactly what configuration lifecycle management is about. So what I'm going to do now is I'm going to move on to talk about, in a scenario like this, a typical scenario with this complexity, where you have these complex configurable products, how do you get started? But before I get to give you some examples, I'd like some input from you. So we're putting up a poll just to try to get some interaction in this otherwise very one-directional dialogue. And the question we'd like to ask to you is, if you think about this CLM journey, if you sort of think that you buy the vision, you'd like to get this connected, you'd like to get alignment between the different systems, where do you think it would be most beneficial for you to start? If you have already started a journey and you had your chance to start all over again, you could also think, where would you like to start? And we have pointed out some main areas here. It's engineering, sales or marketing, it's service, it's in manufacturing related to the order fulfillment of the configurable products, or is it somewhere else? And we'll keep the poll open for a while and try to get some input on what you're thinking. Where would you like to start? Where do you think it would be the right place for you to start if you had to do that? And then I'm going to talk about some examples. And I would say already, in our view, there's not necessarily one of these that are the right one. It depends on the situation and the context, where you are and what you would like to achieve first. So there are different ways you could go about it. Some start with a more big bang approach. They basically try to do it all in one go, and that could also be an approach. So I can see the answers are ticking in the poll, and we'll just give it a little bit more time, and then we'll summarize what we see you're talking about. And when I go forward and I have some examples I can pick from, I'll try to make sure to pick some that reflects the input we've gotten from you. So Enya, I think perhaps, what do you say? Should we try to close the poll and move on?
Yeah, we've got about 89% that have voted so far. So if you are waiting to vote, please do so now, and then I'll close it in a few moments.
So I can already see it's all over the place, but there are also, yeah.
We're getting closer, almost at 100%. So just the last couple, and then I'll close it up. All right, Henrik, I'm going to close this up now, and then I'll also show the answers.
Yes, please.
There we go. Over to you, Henrik.
Yes, thanks a lot. So this is interesting. So just remember, they are not supposed to add up to 100%, because you could pick one or more. And I can see that some of you have done that, because it adds up to more than 100. So you can see clearly the preference is in sales and marketing to get started and try to get this improved. And second after that is engineering, and then manufacturing and service, and then a few that said somewhere else. So what I'm going to do now is I'm going to make sure I cover examples that start in each of these three top groups you mentioned, and I'll move on to that. But before that, I'm going to give a bit more context, and then I'm going to talk about these examples relating to these three different areas you pointed out as a top. I also have one for the fourth, so just stay tuned. I'll get to that. Thanks, Enya. Then I think we'd like to continue with the presentation.
I'll continue the presentation. Can I also suggest that for those that responded with somewhere else, please feel free to add that in the questions pane, just so that we make sure that we cover it as well later on. All right, yes, over to you, Henrik.
Yes, so to get to how to do it, I'm going to start with how I think not to do it. and this is based on observations on things that have gone wrong out there. Over the 20 years, we have seen other approaches, and we definitely don't recommend any of these. And the first is a big bang, rip and replace across the full value chain. And of course, the problem, I mean, the potential is, of course, if you really change fundamentally how you do your business, then you can achieve enormous value. The downside is it comes with a tremendous risk. So unless you're a startup and you have a greenfield, or you're sort of allowed to take part of your business and do a greenfield, this is really, really risky. Because as you spend time, it takes a lot of time, a lot of things you have to change. As time goes, you're just building up risk. And if you fail, you've spent a lot of time and money on something that does not give you value. And there's a natural risk in this world on digitalization where just things take time, because IT changes all the time. Markets change, IT change. So if you have a project running 4 years, then you can be absolutely sure before you're done, the world has changed and you need to adapt. We don't recommend that. I've also heard some that are striving to just say, you know, the backbone is our bill of material of our products. We just need everybody in the organization to agree about the one universal bill of material. While that might work between some of the disciplines and small functions, it doesn't work for the full company. There are lots of horror stories this going wrong. So we don't recommend that. What we would recommend is a more incremental approach. So here you find a path, and then you take small steps that each create value. And you should get value at each step. And the benefit is that you minimize the risk, you get value faster, and you simply get more comfort in the path you're taking is good. And then you do these steps. And of course, I guess most people will agree on that. That's a very good story. That's a nice slide, Henrik. But how on earth are we going to do that? And I think there are some good examples of how to do it. And this is what I'm going to talk about now. So I think the starting point is to have sort of a vision. What is it you want to get to? And of course, what we talk with companies about is getting to this fully transformed digital configuration lifecycle management view, that you have these linked, you have the processes linked, so it's efficient for you when you need to bring a new or changed product to market. You can do it efficiently, without errors, quickly. And when you have to take orders and manufacture, and you do it without errors. And so if you sort of buy that vision, that's the starting point. You have to think like that. That's where I want to go. And then there are different paths. I'm just illustrating them here with different colors. And I'm going to show some of them. And then pick a path and take the first step, get value out, and then you might actually adjust the journey because you've learned stuff in taking the first step on the path. And here, I think a very important thing is that if you really want to minimize risk, you should start by adding to the existing landscape before removing anything. And that might sound strange because we want to be more efficient, we want to go faster. How do we do that? By adding IT. But it seems in the projects we run, that's the key to success. You add some modern IT that can meet your modern needs before you decommission your legacy. And then when you have shown that it creates value, it's accepted by the organization, it's stable running, then you can start thinking about removing legacy pieces. It's a tremendous weapon in managing risk by doing that. And let me show you some examples where this has all happened. So the first one I want to talk about is Jaguar Land Rover. And this is interesting for those of you who are thinking about starting in engineering, because that's exactly where JLR started. They started in engineering. So JLR is a passenger car manufacturer. You know the brand, I'm sure it's a very strong brand. It's not the biggest of the when it comes to volume, but they're a very strong brand. They say premium cars. They're quite expensive. You can get them with tons of options. There will typically be like 3,000 options on a Range Rover. And JLR, they have to develop their products so that they have engineered all these variations. And if you try to do the math, it's this 5.8 times 10 to the 21st for one of the product lines. You have to know the engineering of all that. Where if you take an order of any one of these 10 to the 21st, you have to know how to manufacture it. So JLR, they started to sign from the engineering side. So they have a team in the engineering department that is responsible for product information. And they work at a feature level to define the configurable products, and they are the starting point. And then they interact with sales to get the market needs. They push it down to engineering. They use it for reuse, because when there's a new product range, you'll typically reuse like 70% of the parts and assemblies from the old one, and they can help with that because that's part of how they do the modeling. So they drive it from engineering. They starting by adding a tool to get that going, which was then running in parallel with the old legacy landscapes. It was feeding a lot of downstream systems. And then as they had that up and running, they took product line by product line. They could see it created value. Then they could start turning off old systems they no longer needed. And they've continuously done that now for 8 years. Up and going, gradually replace legacy. And whenever they do that, they reduce maintenance cost and risk on the legacy systems, but without having this big risk of just turning something off and you don't really know if the replacement will work. So they started from engineering towards manufacturing and sales. ABB is another of our customers, and they started sort of driven from sales and engineering sort of at the same time. So they have products. They explained to this quite convincingly to me that they have products where they sort of explain it like the configurator is the product, because when they deliver it, it basically a lot of parts and components and assemble instructions. So without the configurator that helps find out what are the components and parts you need to use, you don't have a product. So of course that's needed in sales. Otherwise, it becomes a manual process to create an order where you need to involve engineering. So it's sort of driven from a sales need, but quickly they onboarded also engineering, which uses this as an extension of the PLM system to handle configurable products. So it starting sales, quickly moved on to engineering. ThyssenKrupp, they're now called ThyssenKrupp Elevators. They have just been spun out of the big ThyssenKrupp group, and they have a very strong CLM vision of connecting the full value chain from early product design and definition all the way down to what they call modernization and service. So when you install an elevator in a tall building, then they go in roughly 10 years after you installed it, and they offer an upgrade, a modernization of the elevator. And in order to do that, they need to keep track of the configuration and find out what are the modernization offers we can then give them, giving that's the configuration they have in their installed base at that particular point. So they really think it end to end. They started sort of in two different parts of the business. They started two different places. In one part, they started doing sales, improved the sales part. Another part, they started in the engineering side on different product portfolios and in different regions. And I think that's a good example of how you can start. You can pick a product range, or you could pick a region as your starting point. Get it up and going there, make sure it creates value, don't turn off any old systems, make this as an additional tool that can create value. And as you gain confidence, you might realize some of the legacy we can turn off. So here for the 9% who said service, there's actually an interesting example here from Vestas Wind Turbines, global company headquartered in Denmark. the world's biggest manufacturer of wind turbines. And they started the CLM journey in the service side, in particular in the commissioning phase, because when they've installed the wind turbine, they have 163,000 parameters they have to configure. And of course, it's a nightmare to get them right. And if you don't get them right, you might have security issues because the wind blades might overspeed, which would ruin the wind turbine. You might have too much wear and tear on the wind turbine, or you might not produce the power you promised your customer. So they have built a solution they've been using for 17 years now in their service department as a service tool to configure these wind turbines. And they are now adding sales. So they started the journey in service, now adding sales. And of course, adding sales makes a lot of sense because a lot of the parameters you need about the wind turbines when you have to set it, they actually come from a sales process. So they want to make the link between what you're selling and to service. And they're already thinking about how can we link this up to engineering and PLM. But again, I think a healthy phased approach where they at each step make sure they get value and then they add more. That brings me to the last example I have here. It's a company called Case New Holland. They have a number of brands, and one of them is this slightly hidden tractor there you see, but they do agricultural equipment. Sorry, they have Case, they have New Holland. They started from an engineering side towards sales. Again, so they wanted, or I could say what they really want to do was link engineering and sales and manufacturing, but adding a new sales offering. And this is publicly available. If you go to the website, you can find a configurator online, and you can try to play around and configure one of these agricultural equipment. It's quite fun. I think they've done a very good job in getting a nice UI. And what they want to do was make this available for their big dealer network so that they can efficiently configure the equipment and give a quotation to a customer so they could take the order. They had an old system, and this is not unusual, as I talked about before, that they already had a first-gen dealer sales portal. So what they did was they built this new one. They kept the old one open, and I think they had a very bold launch. They said, now we open up this new one. It's you to pick, but we suggest you go in and try this new one out because we think it's so much better than the old one, and then see what happens. And then after 1 week, they had 98% adoption of the new portal, and nobody ever want to go back to the old one, and then they could decommission and remove it. I think that's an interesting approach. And the way they got going on this, I have a very detailed slide. I won't talk about all the details, but just so we get an idea, is that they linked data from existing systems. So they had a backend PLM system that they have developed themselves with a lot of engineering rules. So we're talking more than 500,000 rules that defines how their products can be configured. And they want to have this feed into their SAP processes. So they added this on the side, and it connected the engineering rules from their legacy PLM, and it made it able for them to take orders from dealers and put them directly into the SAP system. So I think this is a very nice approach to get going on a CLM. Add something, make it so attractive that the users just want it, and then you can turn off the old version. So I hope you got some ideas about where this could start. There is, of course, a lot more that could be said on that. But this is sort of what I decided I could cover in this session. And as you could see in the poll, there are ways where you could, different ways where you could start, depending on what sort of you could see could be a first important step for you, or where you have currently a big pain, or where digitalization of otherwise manual processes are on the agenda. So I think there are many ways to get started on the CLM journey. So I can't see why not Why not today rather than tomorrow before competition is doing it? So with that, I'll leave some time for questions.
Software is growing more and more as a part of configurations. Mechanical parts and electronics are managed in PLM, software in the application, lifecycle management. Henrik, can you or can the CLM help in this context to prevent silo building?
Yes. This is that's a good question, and this is an important area because you're absolutely right. The one of you who asked that question, because really many companies are faced with this challenge that now software is such an essential part of their physical products, and how do you handle that? It's a bit new to many, and how do you fit that in? And there are new tools that helps develop these software components, and you need to ensure alignment. And I believe you could do this, use a CLM thinking here, because what CLM is doing is aligning these systems at the right level of abstraction. And we didn't have time to talk about this today, but this level of abstraction we talk about as a feature level. So these different systems, they should sort of talk together at the feature level and not too deep a level. And that's one of the things that goes wrong if you try to do sort of a universal bill of material where everything is in, is that if you're in electrical engineering, you need certain details, but if you're on the sales side and need to communicate to the customer, it's other aspects. And how do you make these systems communicate? You can't expect one to communicate on the premises of the other. That's just going to work badly. So our recommendation is keep the tools that are best for the discipline you need to do, and then link them up at this feature level, which is a nice level of abstraction that makes sense across the business. So that's my recommendation also for the software. And we have some examples of that, where you find the right feature level, and the feature level is sort of the interface between the different aspects. So what is it that's important for software from the mechanical side, and the other way around? So you sort of define the interface at these feature levels, and that's how you link it up. So yeah, that would be my answer to that. That would be the approach I would take. Find the right features to synchronize.
I think that's a great way of explaining that as well. So I've got a question here actually specifically about the CNH example, and that was to ask, is SAP ERP using the Configurator engine, or is Configurator publishing a KBase for SAP ERP into ingest? Is this something you're allowed to divulge? Otherwise, I'll move on to another question.
Yeah, yes, that's okay. I can answer that. So so there are two approaches, which is also sort of indicated in the question. And one approach is that you have the structure in SAP, so the shell KMAT, we call it. So you basically have the structure in place, because if you have the structure in place in SAP, you can use all the processes you have in SAP for finance and manufacturing and whatnot. So you don't have to disturb the processes. But you don't need to do the rules in SAP. You can do them outside. And then it's configured. You can use the configured engine to do the solve and populate the configuration back into SAP. And depending on the situation, we have customers that sort of push it into SAP. And we also have customers that do what they call a call out. So you can sit in SAP, and then when you need to configure, you can sort of open up another UI, which is like using the rest of the organization based on the configured engine, where you do the configuration and store it back into SAP. So you can do that. These couple of different ways of doing it. But I think the key is utilize the process support and flow that's in ERP for what ERP is good at, and then you can add this configuration aspect outside. If you do have the logic in SAP already, in the variant configurator, or in the variant configurator, there is a way to pull that out and use that outside as well. So if you spend years building up product knowledge in SAP, our recommendation for getting started would be reuse that knowledge. Don't start throwing it away and try to rebuild it in another tool. Use what you have, and then over time you might, for instance, if you're going to design a new product, do that in the new setting with the new modeling tool that's more efficient. And then you don't have to also create it in SAP, because you can do this push the configurations back into SAP. So that could give you a smooth way from where you are, utilizing all the knowledge you build up in your knowledge base, but also starting to use more modern tools for the digitalization.
Got a question here that is, would you advise to always have engineering as part of the CLM, and could it
be left out? It does not have to be there in the start, in the sense that if you can just get the engineering data out, if there's some way where you sort of, without disturbing the engineering department too much, just could get the data out, then you can take that and start, for instance, in sales with what you have. But there's a way with the tools where you can sort of add the commercial aspect. You don't have to disturb the engineers. You can add the commercial aspects that you need for sales. So you can make a sort of standalone sales solution, but it would be highly beneficial to get access to the data in the engineering systems, in CAD or in PLM, and pull them out, because it would greatly improve the quality in configuring in sales, because you would know if this is something you know how to engineer or not. So you would basically know if this is an order that's safe to take. So I would recommend to find a way to get the data out and get access to them, because the only alternative is you sort of have to recreate them in a silo, and then you would later have to do some alignment, which in general would not be, I think, a good first step unless there are very special circumstances. It's not what I would recommend in general without knowing the context.
What is the difference between PLM and your CLM? And we'll make this the last question for today.
Okay, yeah, so I'll try to give a short answer to that. So PLM is for engineers and CLM is for the full enterprise. I think that's the difference.
That was nice and short as well, thank you.